The actual function of muscles is not to move a bone, it's actually to generate the force necessary to do so, being connected to a minimum of 2 bones and surrounded by protective layers of sheath that we're going to look at later. So also note down that a muscle will have an origin and insertion. In the origin, the proximal end, so the end closer to the point of attachment, will be usually attached to the less movable bone. So we know that the bicep moves the ulna or radius, I'm not sure what this is, so it moves the arm this direction. It does not actually move the scapula, so this is the less movable bone. And in the exertion will be the opposite, so the distal end, the end further away from the point of attachment, will usually be attached to the more movable bone, in this case the radius or ulna. Tendons will actually be the ones to transfer the force generated by the muscles, and they will connect the muscles to the bones, as you can see here, for example. And lastly, we have ligaments that connect bones to bones, and essentially what they do is stabilize the joints to prevent unwanted movements and dislocation. The fibers that muscles are made of are wrapped around a protective layer of muscle sheath, also known as fascia, and it is made of collagen. So this is made of collagen. This makes it strong and slippery in order to allow holding the muscle in place and separating it from other muscles. An example would be the iliotibial band. This band runs down the thigh, and there is a possible condition where one will experience pain here, and this is called the iliotibial band syndrome. This is often caused by the overuse of this band during sports such as cycling and running, most commonly. The surgery to treat this involves an incision made when the knee is flexed by the band, and it lasts about 30 minutes. If we look at a diagram of a joint, we'll see that the bone is actually the yellow and hollow part that has a spongy texture, as you can see. So essentially, because it's hollow, because it has these holes, this gives it slight flexibility, so it can slightly bend without being broken when placed under pressure or movement. And then we have the white part, which is actually cartilage. Okay, so this protects the joints and bones by absorbing the shocks throughout the body. A fibrous articulation will involve, as the name suggests, fibrous tissue that will connect the edges of the bones where no movement is allowed. So an example of this would be the skull, that is made up of many different bones held together by this fibrous tissue. Moving on to cartilaginous articulations or joints, same thing. This time there will be a little bit more movement, though still limited, and the bones will be separated by fibrocartilage or hyaline cartilage. And an example of this would be the vertebrae. Lastly, we have the most movable joints and the most common in the body, also known as the synovial articulations. So these ones have a synovial cavity or capsule that we saw before, where we labeled the bone and the cartilage. So this only applies to synovial articulations, and there are 6 types that we're going to look at in a second. The neck would be an example of a pivot joint, as it provides an axis that the head can somewhat turn upon. An example of a hinge joint would be the elbow joint, because as we know, it allows flexion and extension. So flexion would be caused by the biceps and extension would be caused by the tricep muscle. Then we have saddle joints. The only example I can think of is the thumb joint that allows slight movement, and well, it looks like a saddle. Then we have condyloid joints, which are modified versions of ball and socket joints that we'll look at later. They allow a lot of movement, and an example of this would be the wrist. If you try moving your wrist, you'll see that you can do so in many directions. Then we have the actual ball and socket joint, which is the most movable in the body and is attached to long bones such as the humerus. An example of this would be the hips or the shoulders, because as we know, they can turn in many different directions, so they are very movable. And lastly, we have the glade or plane joint that has limited movements, and it is composed of plane layers that will glide or slide over each other. So examples of this would be the sternum, and so the sternum is here, and the clavicles, and that would be the 6 types of synovial joints.